This particular tutorial will focus on the footprint analysis toolbox. Let's go into our toolbox and come down here and select footprint analysis. On here we're presented with a map, and there's a pin at the location where our site is. You can find the details down here of the latitude and longitude. So this footprint tool is based on the publication and the algorithms and the computations done by Natasha Clune. If we come to this acknowledgement tab, you can come in here and look at the paper and who these co-authors were. If you want to reach out to them or check out the work on their websites, you can go and select one of those to find out some more information on this tool. We also have a help pane here to give you an overview of what we're going to be doing inside the analysis tool. By clicking on Learn More, you can find a much more detailed help that'll take you to our website. Okay, so let's go ahead and set up a configuration. You do that by clicking on that plus button there on the new configuration. Okay, so on this particular map, we have functionality where we can zoom in. So let's go ahead and do that. And here we have our eddy covariance site. Our tower is located with the pin here, and we have a large grass field, a parking lot, some buildings, and some other industrial areas. So what we'll do first is name this footprint. Let's call it FP number 1. And we go to draw a computational grid. Now the computational grid is the area in which we want to compute the footprint within. So we click on Create. I click and release the button, and then drag my mouse over and click the button again. So the footprint will be computed within this area here. Now I can choose the number of points, say a 100 by 100 grid across this square here. Or alternatively, I can come down here and choose a resolution. So if I have a very large area in which I'm computing the footprint, I might want to have a 5 or 10 meter resolution. If I have a smaller area, I might want to have a 1 meter. So it just kind of depends what resolution you want. Obviously, the smaller the resolution, the tighter that is, it'll take a little bit longer to process. Okay, down here we have a quality flagging region. So this could be an area at your research site that has, say, a footpath or perhaps a lake or a pond or some kind of structure that you don't want to, or that you want to have flagged whenever the fluxes come from that area. So in this particular example, I'm going to draw an area by clicking on this Create button, coming over to the map, and then clicking the mouse and drawing an area. Now I'm going to draw an area here around this parking lot and this building, and I make sure to come back to the first point, and you can see I've created a shaded red area. And we'll talk about later how you can flag your fluxes whenever the flux probability falls into this red area during the analysis period you're looking at. Now let's imagine I have some areas of interest in this particular square that I want to kind of section apart. Maybe I have a heterogeneous ecosystem where I might have like a soybean on one part, cornfield on the other, something like that. In this particular example, I'm going to assume that this north side of my field might have some influences from the roads and the traffic here, and the south side I don't have any influence from the traffic. So I'm going to call this first one North Traffic. I come down here, click on the Add button, and again, like I did previously, I can come in and draw an area around the area of interest, like that. Now let's assume the second one, I'm just going to call it the south, where there's no traffic influence. At least that's my hypothesis. And I can draw, similarly, a square, whatever shape I want, and complete it like that. Now if I want to change the shape of this a little bit, it's pretty easy to do. I click on the Edit button, and then I can drag these buttons around, and for example, let's exclude this diamond shape here. So it's real nice, easy to use tool for drawing shapes in any kind of shape in doing this. Now, when I run this model, it's going to calculate the footprints and all the different regions here. It'll get flagged if it goes anywhere in the red area. And then it'll also keep track of what percentage falls in my north traffic green area and what percent falls in my south traffic area. Okay, so now that I'm ready, I go ahead and I can save this configuration by clicking on the Save button. And it will take me back here to the main footprint page. And what you'll notice is that you have the opportunity here to create multiple configurations. So if I want to go back and, for example, draw some new shapes or draw a bigger computational area, I can just click on, again, this new domain configuration and store a bunch of those settings here. Okay, so when I'm ready to run the model, I can come down here. As the model runs, I can watch the footprints be computed and shown on the plot. If I'm doing something like a year, which I'm going to do now, I could have something like 30 days. Or if I'm doing something smaller like a month, I could have it update every day, something like that. So that just updates and lets you see that in real time as it's happening. So when we're ready, I'll go ahead and select this particular footprint, and we hit the Start key. Now you'll be asked, are you sure you want to do this? When you're doing a footprint model, it takes quite a bit of time to run. I'm going to do about a 1 year period here, which could take about 15-20 minutes. So it just wants to make sure that you know it's going to take a little bit of time and you can't stop it once it's started. So I'm going to go ahead and select this to start. Over here on the right hand side, you will have a log is updating you on which period the footprint's being calculated. Okay, and as this goes through the computations, I'm going to go ahead and end this session, and we'll come back and look at the results in the next tutorial. This tutorial will focus on the footprint analysis results. Now in this one, we're going to visualize the results from the footprint analysis, and we can do that by coming up here, and we start selecting how we want to view that data. We can do a year-by-year analysis. And for my particular data set, I just did 2013, so there's only one option here to choose. I also only did 1 month, the month of July, so I can choose this. Otherwise, I could break this down by calendar season or by year. And again, the month I did is July. And then over here, we have the opportunity to choose to display the results based on the conditions during those measurements. For example, if the ecosystem and the environment was stable or unstable, I can choose one of those. Just look at day or night, something like that. Let's just start out by looking at all the data. So here, the footprint is shown for the month of July, all compiled and aggregated together. Now I have some options where I can change some of the features on this map and drawing. For example, if I want to change the transparency of the heat map, for example, to see if there's any feature in the ecosystem that's contributing to the hotspot, I can go ahead and do that. Down here, I can turn on and off some of the drawing tools. For example, you remember we drew a region of interest around the corn and the soybean fields. I can turn those on and off. I also can look at different background maps. Here, just a street view, or I can come to a terrain view. And maybe I want to investigate the footprint in relation to the topography. Then there's some other tools that might be useful. I can add a compass to the map here, or maybe I want to have the latitude and longitude information displayed on the map. I can choose to do that. So when I'm done with all of these settings, so I can come up here and click on Save Map Image. That'll create a JPEG. I can take that image and perhaps use it in a poster or a presentation, or perhaps even in a publication. I also have the opportunity to export all this data, and this creates a zipped file package with several CSV files. It also contains some PNG files and some SVG files. If I want to take this information and load it perhaps in another software package that I might be working with. Another option we have up here is if I want to go back to the analysis settings, I can go back, create another footprint, and do maybe draw some new regions of interest or new flagging areas and things like that based on the results I see now. Here's another mode in which we can look at the plots in yet another way. So here on the left-hand side, you'll see cumulative footprint, and we can see how the shapes change as you get contributions from the fluxes at the different distances. And over here, we have a windrows, which is also showing the footprint contributions from the different directions. Again, you have those same features that you had on the other plot where I can look at just the stable conditions and switch between looking at different environments of what was happening with the ecosystem, and you can see both plots are updating to those things. I can go back to my original view, and when I'm ready to accept this particular footprint settings and these results, and I want to start doing some QA/QC on using the footprint and perhaps excluding some of the data from my analysis, when I'm ready, I can go ahead and come up here and click onto this Done button and get my footprint analysis features done. When I click on here, I'm prompted to either type in my own name, but for this particular one, I can name it simply with the default date and time stamped as it's shown here. And when I'm ready, I'll go ahead and click Continue. Now, if you want to stay tuned for the next tutorial, I'll show you how to use the QC screening tool and that quality flagging for the footprints. This is the third tutorial. It focuses on the footprint analysis. This third tutorial will now focus on how to use those footprint analysis results to do some QC screening of your variables. Now, if you went through the footprint analysis toolkit, you will have a node here indicating that you've done that. Otherwise, you won't have this ability to screen the data using the footprint. Now, let's quickly look back at the results we had from doing the footprint analysis. This is a map on the left where our footprints are for the month of July. And here we have our flagged area in which we want to potentially exclude flux computations because of the overlap. Now over here I have a simplified diagram showing 3 half hours, X, Y, and Z. And for the first half hour X, we notice that the footprint computations from where the fluxes are coming from have an overlap of about 23% with this flagged area. Now this second half hour, the wind shifted and we have only about a 2% overlap between the footprint and this flagged area. And of course with the third half hour, you see that there's no overlap. Now with this first half hour X, I might not be comfortable with because almost a quarter of my footprint could potentially have come from this flagged area. So I might want to throw out this half hour. The second one, however, almost 98% of my data is still from the area I'm interested in and only a 2% overlap, so I might decide to keep this half hour. Let's go back into Tovi and see how to apply these. I come back in, go to our toolbox, and we go to the quality screening toolkit. Now you'll remember these charts from an earlier tutorial where we clean the data using the min-max thresholds and also doing some date exclusions. So now here we have our latent energy, and we're going to go ahead and clean this data up using the footprints that we've computed. I click here on the quality flag icon, and you'll remember again the focus flag slider that we used for cleaning up our data. And now we're presented with a footprint flag slider as well. If I click here, I can see that it ranges from 0 to 23%. What that means is that during the month of July, and looking at all those half hours, the maximum overlap I had was 23%. Now, as we explained, we might not be comfortable with a 23% overlap, or a 20% overlap, or even a 10% overlap. So what I can do is click on here and slide this down to a level I feel comfortable with. Let's put it at 10%. What that means is anything that had more than 10% overlap into my quality flag area will now be excluded. If I look at my latent energy values, I can now see some yellow points being shown up. And if I look here at the menu, I can see the footprint QC now has about 51 points thrown out in the month of July from using the footprint QC tool, which is about 3.5% of my data. If I'm still not comfortable with that, I can slide this down to, for example, 5%. I'll see another increase in the number of points thrown out, but that might be okay because I really don't want to include whatever's in that quality flagged area affecting, for example, my latent energy, if that's a pond or a river or something like that. Now, when I'm done with this and I'm found an acceptable range for the footprint flags and what do I want to include, then I simply come up here to the Done QC button, click that, and apply those exclusions to my data set. Hello and welcome back to Tovi. This particular tutorial is going to cover the footprint flux allocation tool. Now to use this tool, you will have previously had to run the footprint analysis tool. And if you look at your analysis history up here, you should have a node here that indicates that you've run the footprint analysis tool. Now to better explain how the footprint flux allocation works, I'm going to exit out of the software here real quick to show you a schematic of how this tool best works. Now if you remember in the previous tutorial, you can go back and watch that. It talks about how to set up the footprint analysis tool. We drew some areas of interest on our map here. We have the north side where we feel there should be some influence from passing by traffic on fluxes from this grassy area. And then we created the south side here where we think we probably won't have the same kind of influence from traffic. And what we're going to try to do is allocate fluxes each half hour to one of these two regions. So over here, let's look, for example, if the wind is coming from the north in this particular half hour, which we'll call half hour X, you can see the probability of where the fluxes are coming from. About 60% are coming from this green north area. There's about 40% from kind of an unassigned area, and none of it's entering down into this south area. At the next half hour, let's say half hour Y, the wind shifts direction slightly, and now we have about 75% probability that the fluxes are coming from the north. But we also have some, about 10% here coming from the south area, the yellow drawn box, and maybe about 15 from unassigned areas. Then the third half hour, the wind shifts again, coming a little bit from a southerly direction. We'll call this half hour Z. Now we notice that we have about 80% probability that the fluxes are coming from this south area, maybe 5% coming from the north, and somewhere around 15% are coming from this unassigned area. So now what we want to use this tool for is to designate these particular half hours, if we feel it's appropriate, to one of these areas of interest. So by default, this half hour Z, we'll call it, the fluxes for this half hour will be attributed to the south, the north, and the unassigned because it covers all of those areas. Same with this particular half hour Y. It's going to give the flux value and attribute it to the south and the north equally. And what we want to do is attribute or allocate the flux for this half hour to the north and this half hour to the south. And this half hour, we might decide something different. So let's jump back into the tool to see how we can use this information to make this best work. So we'll come back here, we go to our toolbox, we come down to the footprint flux allocation tool and click on that. And now we're presented with some charts and a map. We have a time series here, our year of data. We have an ensemble average of a variable, and we have our map. So let's zoom back in to our map so we can see what we're working with here. Again, we have our north area where our hypothesis is there's some influence on traffic. We have our south area, which we feel has a cleaner representation of the grass. Now on the top here, let's go ahead and select the variable CO2 flux. And you can see we have an overlay of data points of points that are designated both north and south. They're on top of each other, so you can't see both the yellow and the green, and some unassigned points as well. Now when we look here at the ensemble average, and we have the time of day, you can see that this shape kind of looks weird. We have some strange peaks here around 7 for our fluxes, and we have kind of a low uptake and some strange evening shapes here in the data. As I was talking about earlier, each of these points by default now are designated or allocated to both the north and the south. Over here, if we look at this particular area of the tool, we can see we have 2 thresholds, a north and a south threshold, which we named earlier in the other tool. And what you can do is click on here and see that at a maximum out of all our fluxes, there's a 75% overlap of probability of fluxes during our year that go into the north side. With the south side one, you can see that it goes from 0 up to 75%. Okay, so if we think about our example and say, I'm not going to be comfortable designating a flux to this north traffic area shaded in green unless I have a 50% overlap. Maybe I want to go even greater and have 60 or 70 or 80. I'm going to go ahead and just pick somewhere around 50 for now. What you'll notice now is that points start to get designated to either the south or the north, or they become unassigned. Now similarly, let's do the south area, and I want also to have at least 50% of the probability of fluxes overlapping the south area that I've drawn. And now what's really interesting is you see a clear designation of fluxes from the north and fluxes from the south, depending on the wind direction at that time period. And now, if I look at this over the year, I see something really interesting developing. I can see that the yellow is more what you would expect from an ecosystem of a grassy field. That's this south plot area. But the north has some strange spikes in it for the grassy area. And then, as we look at it, where this peaks are occurring is about from 6 to 9. And if you think about that, that's a lot of that morning rush hour traffic is going by on the roads. And then later in the afternoon, as people are leaving work, again, you see a peak in the traffic. So that's just something that's a really cool aspect of what you can do and tease out differences between what your ecosystem is. Even if you have, say, a cornfield and a soy field, 2 different kinds of ecosystems, you can use this tool to partition or allocate those fluxes based on the overlap and the footprint model. Now, when you're all done with this tool, you can go ahead up here and click the Done Footprint Allocation. And what that's going to do then is create new flux values. We'll have fluxes from the north, fluxes from the south, and some unassigned fluxes as well. And you can use that to do some further analysis on your data. And with that, that will wrap up this particular tutorial.